Good days, guys. My name is Alberto Miner, and today I'm going to discuss SRT521 Lab 8. This is for my video demonstration. It's about clustering using hierarchical agglomerative clustering, HAC. And we have one dataset here downloaded from, this is the dataset from University of New South Wales in Sydney, Australia. And there are 49 different features. And here is their website. And it says that it's a raw network packets. So it's a network traffic packets that it contains in the CSV file, one of the CSV files. Like I said, the lab just required this one to be analyzed. So like any other dataset, we will have to prepare the files, the dataset for machine learning. And so I manually change the contents of the file, make it generic for the protocol. I changed all that, and even the state and the service and so on. But the machine can do that also. I'm just showing you the other way, the manual way, and how I have done that. So like I said, this dataset is a network traffic, contains benign and malicious traffic, and we can see here that there are 49 different features in the dataset. Okay, from here, guys, as you can see, I did manually change the field one by one, like the label. Put 0, 1, and 2. 0 for no, 1 for unknown, and 2 for yes for the label. Okay. So after we clean the dataset and prepare for machine learning, we are doing task 1. It says that create a Python script, perform k-means clustering, different values from k to 5 and 10. Select feature characteristic and unique in the cluster which account for a major population of specific attack family, and present the result in table of k and top 5 features for each cluster, and plot the top features and plot the cluster. So the name of my program is lab8a.py. So let's see this one in action. So here I have this. Okay, so let me run this program. Okay, so it's running. But let me explain it first. So here's the k-means. We just have to iterate the values of k's, and that's what it does here. And it says print the size of the cluster, right? Number of items in its cluster, and the top 5 features, right? Of selected unique characteristics, and then we will have to plot top features and clusters, right? And the centroid too. So what came out in the execution after I run this program is this, and this is a cluster when k is equal to 2. So as you can see here, because my dataset I divided to class or label 0 and 1, and the data points were grouped in the two sets, right? And And this is the output when a cluster is k is equal to 2, as indicated in the program. The centroid seems to not to work properly, but the data points are put in cluster over the label and the data points, right? This is what indicated in the program here, 2, 5, and 10. So let's get the next one. All right, this is k is equal to 10. As you can see, there are 10 colors in total and cluster of 10, and it's printing like that. Okay, so this is for lab 8A. So let's move on to the task 2. So for task 2, we're using feature selection using correlation matrix. And so it says create correlation matrix on all given features. Set up plot as heat map, use person correlation coefficient method for creating matrix, and pick the top values. Compare the feature selected and by the last task, and this one explain your finding. Features which appear both task and 2 and the most significant to machine learning. So the name of my Python program is lab 8B. All right, so let's get this one in action. Okay, moving on to task 3, we have the hierarchical agglomerative clustering, and so we have to make a scatter plot to display the data, the features that we have selected in previous 2 tasks. We'll use only those features for HAC and create an agglomerative clustering object and set the number of clusters to stop 2, 5, and 10 respectively, and fit the clustering object to the data, then assign prediction for each point. And another better visualization tools is dendrogram, and create a dendrogram and check hierarchical clustering. So the name of my program is lab8c.py, and so we will have to see that in action. Just from the previous one, we'll have to just close this. Okay, so this is the lab C right here. Right. We'll have to run. Let's see. We'll have to run it again, guys. And okay, we just have to show all the data set scatter plot over here, right? So that's how the data points look like. So we'll have to do the 2, 5, and 10 cluster. So start with 2 over here, and you see the centroids, and it plot perfectly fine. The centroid is approximately in the middle of its cluster, right? And so we will have to close this one. Let's move on to the next one, I hope. Yeah, right there. And this is the hierarchical agglomerative clustering dendrogram, right? Where the data points are somehow interconnected in each other, right? If we zoom it in, we should see how the data were interconnected in each other. And this is the 5 clusters, right? As you can see, there are 5 colors, right? And the data points were you can say even group or cluster. And so let's move on to the next one. And this is the dendrogram for the 5 cluster. And this is obviously the 10 cluster. K is equal, cluster is equal to 10, right? Or K is equal to 10. And cluster, not K means. And so yeah, there are 10 colors you can see here, 10 groups or clusters of data points that's showing over here, right? So as you can see, the centroid is actually connected, or not connected, positioned close to where the more data points are. As you can see, more dense data points at this point. So all our X were located over here, and those are the like outliers. And this is the dendrogram for the number of clusters equal to 10. Okay, guys. So that's for lab 8. Thanks for watching, and I'll see you again to the next lab. Have a nice day. Okay, guys. So I just ran the program, and as you can see over here, and this one came up, and it came out with the graphic too, and it created a heat map, correlation matrix heat map, and I like that straight line over there. The program calculates the correlation matrix using the percent correlation coefficient for all numerical features in the dataset, and then plots the correlation matrix as heat map using Seaborn and matplotlib. And the heat map visualizes the strength and direction of the linear relationship between different pairs of features. The color intensity and annotation values in each cell indicates the degree of correlation in each other.